This is our last Collins writing for the semester, Collins writing number 8 for Algebra 3. We're looking at transformations of trig functions. So we have a sine function, -3 times theta minus pi over 2 plus 1. And I need you to actually explain using complete sentences or else not full credit, correctly, completely, or not full credit, and clearly, or not full credit. All of the transformations using the proper terminology. So I'll discuss them with you, but you need to write this out. What does a negative do in front of any function? What's a negative do? Well, that's a reflection over the x-axis. What does a 3 multiplied onto the function mean? Vertical stretch by 3, which changes our amplitude when we talk about trigonometric functions, but for any function, it's a vertical stretch by 3. This is a phase shift. It's not simply a translation to the right pi over 2, but a phase shift to the right pi over 2. And then we're adding 1 to the function, which shifts that up vertically, up 1 unit. You need to take that, let's see if I can do this. You need to take that, explain in this area in complete sentences each of those transformations. Me, I'm going to help you. I need you to also graph it down here. So I'm going to use that area up here. I'm going to use this area to make our table to graph those points. Remember that you need to look at the trig paper to see if we're talking about radians or degrees. Since we're in radians, then the table that I construct to find the points will also be in radians. So let's see. I'm going to make a table, I'll do it in blue so you can see it better, with theta. I'm not multiplying theta by anything. It's just shifting, so I don't need another theta row. Don't need another theta row here, but I am multiplying by -3 all of my sine values. So that's what needs to be in the second row, -3 sine. And remember that we put our original sine values down in the bottom so that we can have together the angles that we need to graph with the values that we need on the grid. So let me finish that table out. 3-row table. You know I never make these long enough, so let's try that. What are your values in your table? You always have 0 radians. Then you use pi over 2. Then we need pi. Fourth one is 3 pi over 2. And your last one is 2 pi. What are your sine values? Sine values at these angles. What's the sine of 0? Well, your sine of 0, 0. Pi over 2, 1. Sine of pi, 0. Sine of 3 pi over 2, -1. Sine at 2 pi, 0. Take each of those values, each of that row of the parent graph values, and multiply them by -3. That will both reflect and vertically stretch all at once for us. Those new values are now -3 times 0, 0, -3 times 1, -3, -3 times 0, 0, -3 times -1, +3, -3 times 0, 0. Take those points now, the points of the original angles with the new sine values to graph. So I'm going to graph the point 0, 0. Graph the point pi over 2, -3, pi 0, 3 pi over 2, 3, and 2 pi 0. Let me move this down so we can look at the graph and put those on. So 0, 0, make a nice point. Pi over 2, -3, 1, 2, 3, pi 0, 2 pi, nope, 3 pi over 2, 3, 1, 2, 3, and 2 pi 0. Here's one phase, reflected and vertically stretched, Now I have to continue it to the other side. This is going to continue downward to the next point. My next one, notice, is 2 points over, negative pi over 2, but has to go up to 3. So put a point. Then over to negative pi, it would come down to 0. Negative 3 pi over 2 down to negative 3, and back up to negative 2 pi 0 to extend the graph. And then it would continue up if I continued to the left. All done. So altogether, you need to graph, finding those points, but you have to explain in words, complete sentences correctly, completely, and clearly what these transformations do to the parent graph of sine. Good luck, and this is due on Monday this semester.